Good morning, children. I hope you've already started preparing for your test. First of all, I would like to clarify the doubts many of you had in these question answers that I gave on Tuesday. So, first question was write an expression for pressure at a point inside liquid. Now, for this, you have to just write P is equal to H rho G, where so it is written explain the symbol used, means H is the height of liquid or depth of liquid, rho is density of liquid, and G is acceleration due to gravity. Okay, now some of you had written this one, P naught plus HdG. Now this formula you will write only if they ask you write the formula for total pressure. If they ask you write the formula for total pressure Tp, then you will write like this. Otherwise, if they simply ask expression for pressure at a point inside the liquid, you only have to write this formula. Don't write this. If only they ask total pressure, write this formula. Is it clear, children? And then second one is okay. Third one, pressure at free surface of water in a tank is P naught. Okay, suppose let's take this is a tank containing water, and at the surface the pressure is P naught. Okay, and somewhere below at a depth, pressure at a height h below its surface is P1. Okay, this is height h, and here the pressure is P1. The question is, how are P naught and P1 related? Now, P naught should be what? Atmospheric pressure. Basically, this should be atmospheric pressure. The pressure that is acting on the surface will be atmospheric pressure. So, the total pressure P1, okay, here they are talking about total pressure P1 is equal to P naught plus H rho G. P naught plus, because they have asked how they are related, you have to include atmospheric pressure term also. So the relationship will be this one. P1 is equal to P naught, where P naught is the atmospheric pressure, H is the depth, rho is the density, and G is acceleration due to gravity. The second part, which is more, P naught or P1? Definitely P1 will be greater than P naught, because P1 is this plus something more. So definitely P1 will be greater than P naught. This is the conclusion. Is it clear, children? So fourth one, a diver jumps into the sea. How does the liquid pressure change if he moves horizontally at a particular height? Now, the laws of reflection, laws of liquid pressure, they have asked indirectly in this form. So you know that horizontally in a particular level, the pressure will be the same. It can be this point, this point, this point, this point, pressure will be the same. So that's why he moves horizontally at a particular height, pressure will be same. The answer for A part will be, first part will be pressure will be same. Second, he dives to a greater depth. Okay, so from here he is diving to a greater depth, then pressure will increase. So for this, it will be no change in pressure. Reason also you have to write no change in pressure, because pressure is the same in a horizontal. Now you have to write that law of liquid pressure that you have here. So you will write this one. In a stationary liquid, pressure is same at all points on a horizontal plane. That is the reason for your answer saying that there is no change in pressure. Reason will be that point. Then he dives to a greater depth, pressure increases. Pressure increases. And reason, again, which point you will write? I think the last but one. No. The first one, pressure increases with increase in depth from its free surface. This will be the reason. So instead of asking as laws, they are asking you these kind of questions. These are called application questions. Is it clear, children? So I hope you understood how to write these answers. So now a quick recap of this chapter, of how to study for this test. So this A part I taught you recently, so I'm sure you're familiar with what to study. And numericals, the one we did in Zoom class, only 3, 4, 5, 6 and 7. Rest all is not in the syllabus. Okay, so you don't have to see them. Then come quickly to the D part of the previous chapter, Newton's third law of motion. So statement you will study first, Then you will have characteristics or conclusions of action and reaction force. There are these 3 points. Then examples of action and reaction force. As I told you, it's very important to write it clearly. Force equal to its weight, if possible the direction on the table in a downward direction. By what, on what, in which direction, due to what. If all the information, what all information you can write, try to give direction and due to what and all that. Okay, so don't write it as a story. I want it the clear, the information should be clear. The force exerted by this on this due to this, something like that. Okay, so please study it carefully. Don't just write your own stories here. Okay, now here there's one question. Comment on the statement, sum of action and reaction force of a body is 0. Can you say action and reaction, sum of action and reaction force? We say action and reaction force are equal and opposite. In the sense, if action is plus 5 Newton, reaction is minus 5 Newton, then they should cancel each other. No. Okay. You can't say that their sum is 0. Why? Because action and reaction do not act on the same body. Okay. Action will be acting on one body. See, if you take the example of a book on a table. So the action is on this table, reaction is on this, means 5 Newton force is on this book and 5 Newton on the table. Now you can't add these two because they are on two different bodies. So the answer will be, the statement is wrong because action and reaction do not act on the same bodies but on two different bodies. Okay, this will be the answer. Please pause the video and note it down. Then comes the E part, statement of law of gravitation. Okay, state Newton's law of gravitation, study it as such. Then force, formula for force based on Newton's law. Unit of capital G, value of capital G. Then all these characteristics of gravitational force. Then I said there are going to be logical questions based on this. I had explained you already. Then importance of law of gravitation. Then in this paragraph, the information is basically how does value of G change in poles, equator, when you go down, go up and all that. So if you study this information, it's fine. Then relationship between small g, capital G. For that you should remember this one, small g is equal to capital G, capital M upon r square, where M is mass of Earth, r is radius of Earth and G is gravitational constant. Now regarding free fall, all numericals only will come. Mass and weight, it's a very familiar one. Just study this comparison of mass and weight. And this 1 kgf is 9.8 Newton and 1 gram force is 980 dyne. That's all. Okay, and then come straight to the numericals, and you have numerical from 1 to 18, 19 and 20. 20 is not there in the syllabus, you can just cancel it out. And the first 10 numericals are based on the formula for weight, like W is equal to M into G. Okay, and all that based on this formula. Okay, mass will remain the same, but weight keeps changing depending on acceleration due to gravity. Okay, so mostly this is the formula. And surface of moon weight, the G on surface of moon will be 1/6 the value of G on Earth and all that. So one main conclusion, if see this question, third one, calculate the weight of a body of mass 10 kg. If the mass of a body is 10 kg, and if I ask the weight in kgf, what you have to do, just have to write the same value and write it as kgf. If only I ask the value in Newton, you should multiply it with 9.8. For Newton, you have to multiply it with G. For kgf, you need not multiply it with G. Same way, if I give the weight in kgf and ask you to find the mass, you just have to write 10 kg. You don't have to do any conversion, just write 10 kg. But if weight was 10 Newton, then the mass will be 10 upon 9.8 kg. That will be the mass. Okay, so go through all the numericals, try and solve them so that it will be easy for you to recollect. All the best, children. If you have any doubt, you can WhatsApp me and ask. Thank you so much.